a right triangle. The key here, these trig functions only are defined if the triangle is right. So you must have a 90-degree angle. So let's say I have triangle ABC and angle C is my right angle. Then let's define our 6 trig functions from angle A. Okay, keep in mind, if I had my trig functions from angle B, they will be different. So we do have to watch these angles now. The other issue with the 90 degrees, when we're talking about our SOHCAHTOA definition, you cannot use the right angle. The issue becomes that in the right angle, your hypotenuse is also your opposite side, and then you end up with 2 adjacents, and so that definition doesn't really work. So the SOHCAHTOA definition that I showed you before only applies to an acute angle, not the right angle. Common practice, your sides are lowercase letters that go across from your angle, so this would be like side A, side B, and side C. So I told you so, S-O-H. So sine is the opposite over the hypotenuse. So from angle A, what's our opposite side? Side A, and the hypotenuse is C, A over C. Cosine, cosine is adjacent over hypotenuse. Okay, so from angle A, the adjacent side, adjacent means touching, so the side touching it that is not the hypotenuse would be B over our hypotenuse, which is C. TOA, tangent is opposite over adjacent. So from angle A, my opposite side is A, my adjacent side is B. And then once you have those, the others are just reciprocals. So cotangent is the reciprocal of tangent, so adjacent over opposite, or B over A. Secant is the reciprocal of cosine, so hypotenuse over adjacent, or C over B. And cosecant, reciprocal of sine, so hypotenuse over opposite, which is C over A. So now we will be looking at triangles, and I can pick one of the 2 acute angles in the triangle and ask you to tell me all 6 trig functions from that. Don't be surprised if sometime in the not so distant future I might give you a quiz with a triangle just like that, and I might ask you, the SOHCAHTOA definition or from the sides, just a very basic quiz, making sure you know those values. Maybe like Wednesday-ish, if I were to do that. Okay. Let's look at an example. So triangle ABC is a right triangle. I'm going to go ahead and just draw it. If you want, you can write down the words, or you could just draw the picture for your example. It doesn't matter which angles are A and B, they just have to be the two acute angles because I said C was 90 degrees. Okay, I'm going to tell you side A equals 6. The most common mistake that I see on these problems is not putting the sides in the right spot. When I say side A, that goes across from angle A. So this is my 6 down here. Side C, so across from angle C, that's my hypotenuse, is 10. Find the 6 trig functions of angle A. So what else do I need to do here? Find my B. So I know A squared plus B squared equals C squared. The nice thing about these, we're just talking about a triangle. Would we have a negative side? No, so my B is just a positive 8. So I said everything from angle A, which is very important. When you write sine, I expect you to write sine of A, cosine of A, tangent of A. You can't just tell me sine equals. I have to know what angle you're viewing from. So sine, opposite over hypotenuse, so my opposite side is 6, hypotenuse is 10. 6 over 10, just give me a fraction in lowest terms, so that would be 3/5, which means I know automatically what other function. Cosecant would have to be 5/3. Okay, cosine. Adjacent over hypotenuse. So my adjacent side is 8. My hypotenuse is 10. 8 over 10 reduces to 4/5. So that means secant would be TOA. Tangent is opposite over adjacent. So from A, my opposite side is 6. My adjacent side is 8. 6 over 8 reduces to 3/4. So that means cotangent is 4/5. Any questions about that? It's really what we have been doing before, just a little bit different. Instead of giving you an ordered pair or something to start with, we're looking at a triangle and focusing on SOHCAHTOA. Do we need another one like that? I'm only seeing like 2 people in. Do you guys want one? No? You're okay with that? Keep in mind you might have radicals show up in this, so I expect just radical lowest term. Pull out any perfect squares if you can, get your radicals off the denominator if that happens. The next piece I want to talk about are cofunctions. Our cofunctions. Sine goes with cosine. Tangent and cotangent. Secant and cosecant. Okay, so this is a different property. We've talked about reciprocals before. Cofunctions are different. Cofunctions are equal when their angles are complementary. What I the sine of 10 degrees is going to be equal to the cosine of 80 degrees. The angles are complementary, the cofunction values are the same. So I want to look at an example using this. We're just going to fill in the blanks. So sine of what would equal the cosine of 30 degrees? 60. You're just finding the complement. You just have to do 90 minus 30. Okay. Tangent and cotangent are cofunctions. So this one we actually have to think about a little more. The tangent of 2y minus 4 would equal cotangent of blank. How would I find this? Yeah. Well, we don't even have to have an actual value for y, but on part A we just did 90 minus the 30 to find the complement. So what I need to do here is 90 minus this 2y minus 4. What would you do with your negative? Distribute it. And then combine like terms, so you get 94 minus 2y. So you just have to find the complement, whether that's an actual number or an expression. Just do 90 minus your angle and simplify as much as possible. C, secant of 75 degrees equals cosecant of blank. So 90 minus 75 would give me 15 degrees. I'm going to put an example up here and I want you guys to see if you can figure out what you would do. So it's along these lines, but I want you to solve these equations. Tangent and cotangent are cofunctions. That means if they are equal, their angles are complements. So you add your angles together, and it has to equal 90. So combine like terms, so 5 theta plus 5 equals 90. 5 theta equals 85. Divide by 5, you get 70. Part B is the same thing. Secant and cosecant are cofunctions. So again, your angles are complementary. They add up to 90. You get 7 theta plus 6 equals 90. 7 theta equals 84. And theta equals 12. Any questions on that? The last thing I want to do today is going to set us up for tomorrow. There are some angles that show up a lot in trig. We've already talked about some of them. The 0, 90, 180, 270, 360. There are others that we are going to need to know because they come up so much. And those involve 30 degrees, 60 degrees, and 45 degrees. Those are the last three common ones. So what we're going to do today is take a 30, 60, 90 triangle. I've given you a triangle. I've told you what your 30-degree angle is, your 60-degree angle, and I've given you side lengths. So go ahead and draw that triangle in your notes. And we are going to use this to evaluate our trig functions. So I'm going to start by finding all 6 trig functions for 30 degrees. I'm viewing from the 30 degrees. I'm looking from this angle here. Sine. SOHCAHTOA. Sine is opposite over hypotenuse. So my sine value would be 1/2. Cosine. Cosine's adjacent over hypotenuse. So that would be radical 3 over 2. Tangent, TOA. Opposite over adjacent. So that's 1 over radical 3. But we can't leave it like that. So if I multiply by radical 3 on top and bottom, that gives me radical 3 over 3. Cosecant is just the reciprocal of sine. So if sine is 1/2, cosecant would be 2. Secant is the reciprocal of cosine, so that would be 2 over radical 3. Get your radical off the bottom, so that becomes 2 radical 3 over 3. Cotangent is the reciprocal of tangent, so that becomes radical 3 over 1, which is just radical 3. So these are going to be very important. If you're just looking at that right now, you probably think there is no way I would ever memorize that. It just seems too random. But tomorrow we are going to start talking about all the patterns that come up in these special angles, and I have numerous tricks that we are going to use to help us learn these. So today we're just getting them in our notes, so when I start showing you tricks tomorrow, you can verify in your notes that those were the values we set. I want to go ahead and do the same thing, but with my 60-degree angle. So now I'm switching my viewpoint. When you change your angle, your opposite and adjacent sides flip. So my sine opposite over adjacent would be radical 3 over 2. Cosine adjacent over hypotenuse would be 1/2. You notice cofunctions? The sine of 30 equal the cosine of 60. cosine of 30 equals the sine of 60 because they're cofunctions. Tangent of 60, TOA, opposite over adjacent. So that would be radical 3 over 1, which is just radical 3. So tangent of 60 equals the cotangent of 30. Cosecant, just flip your sign. You also know by cofunctions it should equal the same thing as the secant of 30. You get 2 radical 3 over 3. Secant is the reciprocal of cosine, or it'll be the same as the cosecant of 30. And that gives you a 2. And cotangent of 60, reciprocal of tangent, and you get radical 3 over 3. So all the same ratios that we saw before, we just flipped where they went. Okay. I think I have time. I'm going to go ahead and do a 45-degree triangle, and that'll be the last thing I do today. So I want to do the 6 trig functions for a 45-degree angle. If you have a right triangle, and this is 90 degrees, if this angle is 45, what's this one? 45. If those angles are the same, these sides have to be the same. So we could pick any number we wanted for those. Well, let's just make life easy. I'm going to do 1. And then to find your third side, we could do Pythagorean theorem. So my third side would be the square root of 2. So sine of 45 degrees. Does it matter which 45 degree I pick? No, it's going to be the same from either one, so just pick one. Opposite over hypotenuse, so that's 1 over radical 2. Get the radical off the bottom, so that's radical 2 over 2. Do you guys know how, when I'm getting the radical off the bottom, I'm not writing out, but you know what I'm doing? I can write it out if I need to. Cosine of 45. Adjacent over hypotenuse, so 1 over radical 2, and we get the same thing. Tangent of 45 degrees, so opposite over adjacent, 1 over 1, which is 1. Reciprocal of sine is cosecant. So if you just flip your sign, it becomes radical 2 over 1, which is radical 2. Secant, reciprocal of cosine, so radical 2 over 1, which is radical 2. And cotangent, reciprocal of tangent, and the reciprocal of 1 is 1. So those are the 45 degrees. That will be the piece that we pick up with tomorrow. Are there any questions? So you have the rest of the time to work on the homework. We are not doing all of this today. I think we are going to go up through 37. So I will probably just add the rest of them on tomorrow and collect it all on Wednesday. So you can get that first half done.